Okay, so we will be going to discuss today the contents of your learning module number 4, which is also known as the flight controls. So before we proceed in regards to the discussion of the topics regarding the flight controls, so as you can see in the initial parts of your module, I included an airfoil nomenclature. Okay, or we will also discuss the basic parts of an airfoil. Kung ano bang meron, ano ba yung mga composition nung ano, yung nasa loob ng airfoil, no? Because this is very important because this is very important for you to understand yung different airfoil nomenclatures para yung discussion natin all throughout this topic regarding the flight controls ay mas maintindihan ninyo, no? So these are the basic parts of an airfoil, no? Una, okay, an airfoil is a shape capable of producing lift with relatively high efficiency. So ito yung ginagamit natin sa sa aircraft, no, or in airplanes in particular to produce lift um not only on the wings, okay? Although the wings is the one that produces the entire or the majority of the lift sa isang eroplano, pero airfoil din yung ating ginagamit in regards to our stabilizers, the horizontal and the vertical stabilizers. Okay, so these are the basic parts of an airfoil. Una, we have the leading edge. Ito, no? Okay, so yung leading edge ng airfoil, okay, wait lang. Okay, so this is the leading edge. So the leading edge of the airfoil, siya yung nasa unahan, no? Siya yung unang tumatama sa hangin, okay? Kapag sinubject natin siya into an airflow. So yung airfoil, okay, kapag sinubject mo siya sa airflow, okay, yung unang tatamaan ng hangin is the leading edge nung pakpak. Okay? So this is your leading edge. Ito. Next, we have the trailing edge. Okay? So yung trailing edge naman, ito, opposite siya nung leading edge. So kung yung leading edge nasa unahan, therefore, yung leading edge, ay yung trailing edge natin is nandun sa bandang likod. Okay? Yan, dyan sa may endpoint nung airfoil natin. So commonly, ang shape ng leading edge is medyo, because of the leading edge radius, so medyo circular in shape. Then yung trailing edge natin, yung tip ng airfoil, pointed 'yon, okay? Then next, we have the chord line. Yung chord line is ito. Okay? So yung chord line, that is a straight line joining the centers of curvature of the leading edge and the trailing edge of the airfoil. So yung center of curvature ng leading edge at ng trailing edge, okay? So kapag naglagay ka ng isang straight line, so that is considered as the chord line. Okay? Okay, ayan. Next, chord. We have the chord. Ang chord naman, as we can see here, dito, ito yung chord natin. Okay, so the distance between the leading edge and trailing edge measured along the chord line. So in particular, no, yung mismong distance from trailing edge to leading edge is the chord. Wherein yung chord line is just a straight line joining the centers of curvature ng leading edge and trailing edge. Pero yung distance ng chord line is known as the chord. Okay? Then next, we have the mean camber line. So next is the mean camber line. Okay? So what is the mean camber line? So yung mean camber line natin is the line joining the leading edge and trailing edge of an airfoil. So yung mean camber line natin, so ito siya. Okay? So equidistant siya from the upper and lower surface. So ibig sabihin, yung camber line or mean camber line are also known as the camber. Okay? So ibang tawag doon. So sa ibang book, it is also denoted as the camber itself. So yung camber natin, so siya yung nagdi-divide or equidistant yung yung ating upper surface and the lower surface. So kung si chord line, so ito yung chord line natin. Kung si chord line is just a straight line from the centers of curvature ng leading edge and trailing edge, ang mean camber line natin is a curve in particular, no? Kasi hinahati niya yung natin hinahati niya yung airfoil natin equidistant, okay, doon sa upper and lower surface. So that's the main camber line. Then we have the maximum camber. So sa maximum camber, so ito yung the maximum distance of the mean camber line from the chord line. Okay? So as you can see here, kumbaga ito yung yung distance ng or the maximum distance ng camber or the mean camber line to the chord line. So yun yung maximum camber. Okay? Next, we have the thickness to chord ratio, just only maximum thickness. Okay? Ang maximum thickness ito. Okay, so ito siya, yung maximum thickness, yung pinakamalaking portion ng airfoil. So thickness to chord ratio, so maximum thickness or depth of an airfoil section expressed as a percentage of the chord. Then we also have the leading edge radius. So ito yung leading edge radius natin. So the radius of curvature of the leading edge. So the size of the leading edge radius can significantly affect the initial airflow characteristics of the airfoil section. Okay, next we have the we're going to discuss the difference between angle of attack and angle of incidence. Okay, basically ang angle of attack is just an angle formed by the chord line ng ating airfoil and the relative airflow. So, in particular, kapag lumilipad ang isang aeroplano, angle of attack or also known as alpha, that is also where yung ating kumbaga yung name nung ARED department, which is the alpha. So, doon siya kinuha, which is the angle of attack. So, the angle formed between the chord line ng pakpak or ng airfoil and to the relative airflow. Okay. So, in particular, kapag lumilipad ang isang aeroplano, it depends on the, kung halimbawa, it is, kung nagkakaroon ka ng increase ng angle of attack, so nagkakaroon ka ng nose-up tendency. So, tumataas or nagpipitch up yung aeroplano mo, no? Then, kapag mababa naman yung angle of attack, bumababa yung angle of attack mo, so ang tendency niya is, ang naging attitude niya is parang padive, no? Or nose down. So, regarding doon, it varies now regards to different flight characteristics ng isang aeroplano. So, angle of attack, the angle formed between the chord line of the airfoil and the relative airflow. Yung yung hangin na tumatama doon sa ating airfoil. Okay, next. For the angle of incidence naman, so ang angle of incidence, ito naman yung angle between the chord line and the horizontal datum line ng aircraft. So, ibig sabihin, naka-fix ito sa isang structure ng aeroplano. Depende na lang kung that is a movable tailplane or the entire tailplane yung gumagalaw, no? So, basically, kadalasan in regards to the design of the wing, meron niyang kumbaga medyo nakatilt yung airfoil mo. Okay, at a certain angle doon sa mismong structure. So ang tawag doon is angle of incidence. So yung angle of incidence, yung angle formed between the chord line and the horizontal datum nung aeroplano. Wherein the angle of attack is the angle formed between the chord line of the airfoil and the relative wind or the relative airflow. So we also have the center of pressure. Okay? Yung center of pressure naman, it is a point on the chord line ng ating ng pakpak wherein the lift or the aerodynamic force is considered to act. Okay? So as we can see here, dito sa illustration na to, no? Ito yung airfoil natin. So at that location, ito yung CP. Okay? Center of pressure. So, ano siya, yung point wherein doon sa chord line ng pakpak natin, kung saan yung lift and also the aerodynamic forces are assumed to be doon siya concentrated. So, as we can see here, doon sa mismo center of pressure natin, we have the lift. That is, ito, pataas siya, no? And we have drag, the one that opposes the thrust. So, we assume that those aerodynamic forces are acting along or concentrated siya doon sa ating center of pressure. Tandaan nyo kapag nag-increase ka ng angle of attack, yung center of pressure mo nagmo-move forward. Kasi ang center of pressure, gumagalaw yan within the chord line of the wing depending on the angle of attack ng airfoil or nung pakpak. No? Kapag nag-i-increase ka ng angle of attack, meaning tumataas ka ng angle of attack, yung center of pressure mo is moving forward. Okay? Until such time na yung center of pressure mo will go beyond na sa mismong structure ng airfoil natin. Therefore, there will be now yung tinatawag nating stalling. Okay? Hindi ko kasi mapagana yung wait lang. Okay, sige, anyways. So so that's the center of pressure. The point wherein the chord line of the wing or the airfoil, wherein ina-assume natin na doon mag-act or concentrated yung ating aerodynamic forces like the lift and the drag. So kapag nag-increase ka ng angle of attack, so anong nangyayari sa center of pressure mo, it moves towards the leading edge. Okay? So nagmo-move siya towards the leading edge until such point wherein it reaches your critical angle of attack. At kapag naglumampas ka pa doon sa critical angle of attack na yon, which is also known as the stalling angle of attack, so yung mismong center of pressure mo will go beyond na doon sa mismong airfoil. So meaning, di ba sabi natin, that is the point wherein yung aerodynamic forces are considered to act. So kung wala na yung center of pressure mo within the airfoil section, okay, meaning wala nang aerodynamic forces that is present doon sa pakpak natin. Therefore, stalling will happen. So wala ka na na-form na or napoproduce na lift. Kapag naman ang angle of attack mo ay bumababa, or sabihin nating nagdi-decrease yung angle of attack mo, yung center of pressure mo naman is moving towards the trailing edge. Okay, so that's the difference between the two. So yung angle of attack, kung angle of attack nag-i-increase, umaangat ka, okay, yung angle of attack mo, center of pressure, lumalapit sa leading edge. Until such point na lumampas siya sa leading edge natin, wherein doon na mangyayari yung stall. Okay? Then, we also, kapag bumababa naman yung angle of attack, kunwari nose down, okay? So, ang tendency naman ng ating center of pressure, it moves further from the leading edge. So, papalapit naman siya sa trailing edge natin. Okay, no? So, that's the reason why I incorporated the airfoil nomenclature as an initial topic regarding the flight controls kasi regarding this discussion natin, no, medyo mas specific yung mga terms na sinabi natin or diniscuss natin initially dito doon sa magiging discussion natin all throughout the contents of the module. Okay, then we'll go now with our lecture proper. So we're going to discuss now the flight controls.
The aim of this series of lessons on flight controls is to describe the various primary and secondary flight controls that are available to you, the pilot, and to explain the mechanics of how the pilot's flight deck inputs cause the controls to move. The aerodynamic reasons why
Okay, so basically, in regards to this module, so we're going to discuss the lessons on flight controls, and we will going to describe the various primary and secondary flight controls ng isang aeroplano. Okay? And we're just going to explain the mechanics of how the pilot's flight deck inputs cause the controls to move.
Why flight controls have the effect that they have on the aircraft is outside the scope of these lessons. We will only touch on the theory here when it is necessary for reasons of clarity. In this first introductory lesson, we will look at how an aeroplane moves around its axes.
Okay, so primarily, an airplane has 3 axes. Okay, kapag singular, that's axis, A-X-I-S. Kapag plural, that's axis, or A-X-E-S. Okay? So, ayan.
For steady flight, the aircraft must be in a state of balance, with 0 moments around its axes.
Okay, so when we say steady flight condition, it is the point wherein the lift is equal to the weight, and lift is equal to weight. So meaning, hindi siya nagka-climb, hindi rin siya nagde-descent. Okay? Pero hindi ibig sabihin nun that the thrust is also equal to the drag, wherein imposible yon na nakalutang lang yung ating aeroplano within the air, no? So pag sinabing steady flight condition, so siya, the lift is equal to the weight. So hindi siya nagka-climb, hindi siya nagde-descent. It's also known as the cruising cruising condition, no, ng aeroplano. So at cruising condition, so steady flight siya. So it must be in a state of balance with 0 moments around its axis.
The primary flight controls are designed to enable this to be achieved for all possible configurations and center of gravity positions. The controls are also required to maneuver the aircraft around its 3 axes. The 3 axes about which an aeroplane rotates are the lateral axis, the longitudinal axis, and the normal axis.
Okay, so these are the 3 axes ng isang aeroplano, no? First, we have the lateral axis. Ang lateral axis, kumbaga wingtip to wingtip. Okay, so yun yung lateral axis natin. Then, we have the longitudinal axis. So, yung longitudinal axis lies along the nose up to the end of the tail portion, no? Nose to tail. Kung ang lateral axis, wingtip to wingtip, ang longitudinal axis naman is from nose to tail. Then we also have the normal axis, or also known as the vertical axis, so siya yung nakapatayo, no? All those 3 axes, no, lahat ng 3 axes na yan, they intersect at one common point sa isang aeroplano. So yung one common point na yan, ayan yung gitna na yan, is also known as the center of gravity, or the CG. So that is the point wherein those 3 axes intersect to each other. So that is the center of gravity.
The movement around an axis is produced by changing the aerodynamic force on the appropriate aerofoil, wing, tail, or fin. And this may be done by changing the camber of the aerofoil.
Okay, regarding the movement of the aircraft around its axis, okay, it is done by changing the aerodynamic force ng pakpak, no? Or nung sabihin nating appropriate airfoil. Actually, no, ang airfoil, hindi lang siya ginagamit sa pakpak. Okay? Ang airfoil is also used on horizontal stabilizers and also in the vertical stabilizers. The main difference between the two is that sa ating sa wing, okay, ang airfoil na ginagamit natin is asymmetrical airfoil wherein yung camber mo, okay, although yung sabihin nating yung camber no, ano siya, equidistant, di ba, from upper surface and to the lower surface yung airfoil. Pero hindi siya equal totally. Okay? So hindi siya symmetrical yung upper and lower surface ng airfoil natin, no. So that's the asymmetrical airfoil. So commonly used siya sa pakpak sa wing. Pero sa stabilizers, horizontal and vertical stabilizers, ang common natin ginagamit is the symmetrical airfoil. As you can see here, this is a symmetrical airfoil. Kapag yan na hinati mo sa gitna, although yun nga, yung camber, no, pag hinati mo yung camber dyan, so yung camber sa taas, or yung sabihin natin yung upper surface ng airfoil, lower surface ng airfoil is almost equal to each other, symmetrical siya. So kadalasan siyang ginagamit for the stabilizers. Okay? So by changing the aerodynamic force on the appropriate airfoil, so doon nagkakaroon ng movement around an axis. So, una, this can be done by changing the camber of the airfoil. So, yung diniscuss natin kanina, okay? Yung mismong, we're altering the entire shape of the airfoil, okay, for us to produce a change in the aerodynamic force. Therefore, to provide a movement around that axis.
By deflecting a control surface,
okay, by means of deflecting a control surface, so we are changing the camber of the airfoil.
Changing the angle of attack or incidence of the aerofoil.
Okay, so changing of angle of attack or angle of incidence, typically kapag movable tailplane yung ating ginagamit, no? Or the entire horizontal stabilizer yung mismong gumagalaw to compensate for the control ng pitching.
Or decreasing the aerodynamic force by spoiling the airflow.
Okay, so ito yung last na pwedeng gawin, no, to produce a movement around an axis is to decrease the aerodynamic force by means of spoiling the airflow or by means of the spoilers, as you can see here. So yung spoilers are commonly fitted doon sa upper portion ng pakpak natin. So we will discuss more into details yung mga bagay na to doon sa mga susunod na topic.
The most common method used is to change the camber of the aerofoil. This is done by deflecting a control surface on the trailing edge of the aerofoil, either up, decreasing the camber and the amount of aerodynamic force generated, or down, increasing the camber and the amount of force generated.
Okay, so yung flight controls natin that is commonly located sa trailing edges ng control surfaces natin, no? Nagkakaroon ng movement around the axis ng isang eroplano, okay, by means of the deflection of that control surface. So binabago natin yung camber. So kapag nag-deflect siya upward, so dinidecrease natin yung camber and also the aerodynamic force. Kapag nag-deflect siya downward, so we are increasing the camber. So ito yung camber, no? Yung from kumbaga from leading edge to trailing edge. Hindi yan yung straight line. So equidistant, no? Kumbaga from leading edge to trailing edge. So we are increasing the camber from this location, no? From this situation kapag dineflect natin yung ating flight control or control surface downward, and thus increasing the aerodynamic force.
This principle can be applied to control about each of the axes. The aircraft rolls about its longitudinal axis. The devices most commonly used to control roll are the ailerons.
Okay, be specific now with the terms around, about, and along. Although yung around and about, almost similar naman yon. Pero you must be critical with the terms about and along. Okay. the aircraft rolls about its longitudinal axis. So meaning these are longitudinal axis, no? From nose to tail. Okay? So yung aircraft nagro-roll about. So paikot siya dito. Okay? Paikot siya doon sa ating horizontal, paikot siya doon sa ating longitudinal axis. Okay? At ang mismong flight control that is responsible for rolling ng eroplano is the ailerons. Ailerons are located along the lateral axis. Kasi ito yun eh. Di ba? Ang lateral axis, wingtip to wingtip. So meaning, yung ailerons are located almost along, no? Doon sa lateral axis natin. But, yung kanyang movement, okay, when it is being kapag pinagana natin or dineflect natin yung ailerons natin, so ang cause ng movement niya is rotation about the longitudinal axis. So kapag about, paikot doon sa axis natin, kapag along, within that axis siya, no? So yun yung movement niya. That's also the reason why ailerons provide stability along lateral axis. So ang pinaprovide niyang stability along the lateral axis. But in regards to its movement, okay, nagmo-move siya about the longitudinal axis. So nagro-roll siya either rolling clockwise or counterclockwise. So yun yung parang or roll to the left or roll to the right, paikot, no? So yun yung kanyang movement. So yung pag sinabing roll, it moves about the longitudinal axis at ang flight control na responsible for rolling is the ailerons. And ailerons are fitted, okay, doon sa ating pakpak. There are some ailerons, commonly, no, ang ailerons are fitted on the outboard of the wings, but for large airliners or large aircraft that is operating at high air speeds, there are also ailerons fitted on the inboard portion ng pakpak.
The ailerons are operated by rotating the control wheel or yoke, or by moving the control column or stick laterally.
Okay, so ang movement ng, if you're the pilot, ang movement ng ailerons mo is by means of the control yoke, no? Kung yan ay Airbus, you're using just the control stick, okay? Kapag yan ay Boeing or other type of aircraft manufacturers, they are using control wheel or control column or yoke, okay? So, yung movement na yan is depending on the movement also in the control column. So, kapag yan na inikot mo, nirotate mo clockwise, so mangyayari, yung aircraft mo will roll to the right. Kapag nirotate mo siya counterclockwise, the tendency of your aircraft is to roll to the left.
Rotating the control wheel clockwise will cause the left aileron to move down and the right aileron to move up.
Okay, so kapag yung yung control column natin, okay, minove mo ng ganyan papunta sa kanan, okay, ang mangyayari sa aileron mo doon sa right wing, it will move up, okay?
The aircraft will cause the left aileron to move down.
Okay, kapag ganyan, no, minove mo yung control column mo, no, papunta sa kanan, ni-rotate mo pa kanan, yung right aileron mo, ang tendency niya, or right ailerons, is to deflect upward. Then yung left ailerons mo is to deflect downward. Okay? Sabi natin kanina, kapag nagkaroon ng deflection upward, yung nag-deflect upward yung ating control surface, it decreases the camber and also decreases the aerodynamic force. Once the control surface is being deflected downward, so nagkakaroon ka ng increase ng camber and you're increasing the aerodynamic force. Since there is a decrease in the aerodynamic force on the right wing and an increase in the aerodynamic force in the left wing, the tendency of the aircraft is to roll to the right. Kasi mas mababa yung lift na na-generate sa right wing compared dun sa left wing. So, ang tendency, umangat yung left wing mo at bumaba yung right wing mo. Therefore, you are rolling to the right.
And the right aileron to move up.
So yun yung nangyayari, no?
The aircraft will bank to the right.
Or bank or roll to the right.
Counterclockwise rotation of the control wheel will have the opposite effect. That is, the aircraft will bank to the left.
Okay, kapag naman rotate mo yung control wheel mo, control column, or kapag sabihin natin yung control stick, yung ginamit mo, no, lalo sa Airbus, parang joystick lang siya. Kapag ginalaw mo siya papunta sa kaliwa, or yung control column is inikot mo counterclockwise, ang tendency naman niya, ang ailerons mo sa left wing will go up. Okay? It will go up. Then, yung ailerons mo sa kanan will go down. Therefore, there is an increase in lift doon sa right portion ng pakpak and a decrease in lift doon sa left portion ng pakpak. So, ang tendency nasa left wing, so since mababa yung ano niya, yung lift niya, so parang bababa siya, no, konti. Tapos yung right wing, since mas mataas yung lift na nag-generate, aangat siya. So therefore, your aircraft is banking papunta sa kaliwa. You are rolling to the left. So that's how the aileron, in coordination with the control column or control stick or yoke, is being concerned, no, by means of the pilot's operation.
The aircraft pitches about its lateral axis. Pitch control is most commonly achieved by the use of elevators.
Okay, in regards to pitch control, the aircraft pitches about, this is your lateral axis, okay? The aircraft pitches about the lateral axis, so paikot sa lateral axis. So ang paikot sa lateral axis, it can be either pitch up or pitch down, or nose up tendency or nose down tendency, na. So pitch control is most commonly achieved by the use of elevators. So commonly, ang elevators are located at the trailing edge of your horizontal stabilizers, but there are also some aircrafts wherein the entire horizontal stabilizer yung gumagalaw. Okay, that also that acts as the elevator that produces pitching. Okay, so yung tawag doon is the stabilator. So ayan yung movement ng ng elevator. So kapag nag-deflect yung elevator, it will cause movement around the lateral axis. Okay? So ang tendency ng aeroplano, it can either pitch up or nose up or pitch down.
The elevators are controlled by moving the control wheel or control column fore and aft. Pushing the control wheel forward.
Okay. So pushing the control wheel, control column, or yoke, or kung Airbus aircraft man yan, yung control stick, forward, okay? So kapag pinush mo siya forward, ang elevator mo will deflect downward. Okay? So, meaning, kapag nag-deflect siya ng downward, it increases the camber. Okay? It increases the camber nung section natin doon sa horizontal stabilizer, and therefore increases the lift or the aerodynamic force. And since there is an increase in lift, so aangat ngayon yung buntot mo. Okay? Aangat yung tail. Therefore, it generates pitching down tendency, no, or pitching down movement. So yun yung yun yung nangyayari. Kapag pinush mo yung control column or yung yoke, so magde-deflect downward yung ating elevator, increasing the camber and increasing the aerodynamic force. Therefore, it creates a nose down tendency doon sa aeroplano natin. Kasi mas mataas yung lift na na-generate sa buntot eh. So angat yung buntot, then yung nose natin bababa.
Lowers the elevator and the aircraft pitches down. Pulling back on the control wheel raises the elevator and the aircraft pitches up.
So kapag hinila mo naman, okay, kapag pinul mo yung control wheel or yung yoke or yung control stick, okay, so ang mangyayari naman sa elevator mo, magde-deflect upward. So kapag nag-deflect upward, you are decreasing your camber, then you're also decreasing the aerodynamic force on that control surface. Therefore, ang mangyayari, magkakaroon ng nose-up tendency yung aeroplano or it will pitch up. Okay, so that's how the operation of the elevator works, no? In regards to cockpit controls.
The aircraft yaws about its normal axis. Control in yaw is normally achieved by the use of a rudder.
Okay. Yung yaw or yawing, yung movement na to is about the normal axis. Paikot naman siya sa normal axis. Okay? Pag sinabing normal axis, also known as the vertical axis, no? Okay? So, kapag nag-rotate about the normal axis, so that is yawing. So, yung control in yaw is normally achieved by the use of a rudder. Ang rudder is located on the leading edge portion ng ating fin, or tail fin, or also known as the vertical stabilizer. Okay? So, doon sa trailing edge ng fin natin, ng vertical stabilizer, doon nakaposition yung rudder. It provides yawing to the aircraft, no? It will yaw either to the left or yaw to the right.
The rudder is controlled by the rudder pedals.
Okay, ang rudder is being controlled by the rudder pedals. So basically, no, in regards to landing gears, itong rudder pedals na ito, sige, later.
Pushing the left pedal forward causes the rudder to move to the left.
Okay, so once you push the left rudder pedal forward, okay, ang mangyayari sa rudder mo, it will deflect to the left. Okay? So kapag nag-deflect siya doon sa kaliwa, so meaning you're increasing, there will be a change in camber, no, dito sa location na to. So ibig sabihin, mas mataas yung lift na na-generate doon sa right portion ng ating ng rudder. Since mas mataas yung lift dito, okay, kumbaga, itutulak niya ngayon papunta naman sa kaliwa yung aeroplano. So, in regards to yaw control, kung saan nag-deflect yung rudder, doon yung movement ng aircraft. So, dito, nag-deflect siya sa kaliwa by pushing the left rudder pedal forward. Therefore, the aircraft will also move to the right or will yaw to the right. By the way, no, yung symbol na to, that is for the center of gravity. So, yun yung symbol na ginagamit natin for the center of gravity.
And the aircraft knows to your left. Pushing the right pedal forward causes the rudder to move to the right, and the aircraft knows to your right.
Okay, so kapag pinush mo naman yung right rudder pedal mo forward, therefore the rudder will deflect to the right. Okay? So it will deflect to the right. So ang tendency ng aeroplano mo is to yaw to the right. Okay? So kapag pinush mo yung left rudder pedal, ang mangyayari, it will yaw to the left. Pag pinush mo yung right rudder pedal, ang mangyayari, it will yaw to the right, no? Yung magiging deflection niya is also papunta sa kanan. Yung deflection ng rudder mapapunta sa kanan. And your aircraft will yaw to the right. So that's how the movement of the rudder is being controlled, no, sa cockpit. So kapag kaliwa, pag pinush mo yung kaliwang rudder pedal, mag-yaw to the left. Pag pinush mo yung right rudder pedal, mag-yaw to the right. But if you push the two rudder pedals simultaneously, that is where aircraft braking is being operated. Kapag nasa ground, no, kapag sabay mo siyang tinapakan yung left and right rudder pedals, doon gagana or mag-engage yung braking system ng wheels natin. Pero kung isahan lang naman, actually hindi mo naman yung magagamit while in flight, no? Magagamit mo lang yan once the aircraft is on the ground. So doon lang siya magiging operative. Pero in regards to the movement of the ng rudder natin, so it can be either you're pushing the left rudder pedal forward or you're pushing the right rudder pedal forward also. So there is a huge difference between the operation ng control surfaces natin, no, sa aeroplano, and also in regards to automotive vehicles.
The ailerons, elevators, and rudder are known as the primary flight controls.
Okay, when we say primary flight controls, it is classified as lahat ng eroplano ay meron ito. Okay? Meaning required siya, no? Kasi if you do not have an aileron, paano magiging control mo in regards to rolling? 'Di ba? Kapag elevator naman, paano ka makakapag-pitch up or pitch down? Kapag rudder, paano ka makakapag-yaw? So, that's considered as a primary flight controls, no? So, lahat ng eroplano is merong ailerons, elevators, and rudder. But, there are some instances wherein a specific control surfaces are combination of the two. Pero basically, ang function nila can also be, kunwari, for ailerons and elevators, no? It can also provide pitching and yawing. For elevators and ailerons na combined, okay, so it can provide rolling and pitching. So it depends, no? Pero considered siya as a primary flight controls. And although primary siya, so lahat ng aircraft is may ganyan, pero there are some aircrafts wherein yung mismong control surface na yon is combination of the two.
That is the end of this introductory lesson. You now know that ailerons control the roll of the aircraft about its longitudinal axis.
Take note ha, ailerons control the roll of the aircraft about, okay, paikot sa longitudinal axis natin.
That elevators control the aircraft's pitch about its lateral axis.
Okay, so elevators control the pitch of the aircraft about its lateral axis.
And that rudders control yaw about the normal axis.
Okay, take note of this. Ang movement ng ailerons ay about longitudinal axis, but it promotes lateral stability or stability along the lateral axis. Take note of the two terms, along and about. Elevators control the aircraft's pitch, okay, about its lateral axis. But elevators provides stability on an aircraft along its longitudinal axis. Okay? Then the rudders control the yaw ng aeroplano about the vertical or normal axis. And the rudder provides stability ng aeroplano natin doon, or it provides directional stability. Okay? Doon na yan, directional stability, yun na yan. So kung ang ailerons, ang movement niya is about longitudinal axis, pero ang stability niya is lateral stability. Okay? Ang elevators naman, ang movement niya is about lateral axis, pero it promotes stability along longitudinal axis or longitudinal stability. The rudder, okay, ang movement niya is about the normal axis, but it provides directional stability. So those are the differences between the three primary flight controls.
In this lesson, we will discuss the primary flight controls which control and balance the aircraft in pitch.
Okay, so this is for the pitch control. Now we're going to discuss the topics under pitch control into details.
Longitudinal control is achieved by the use of elevators, which are flap-type controls normally fitted to the trailing edge of the tailplane or stabilizer. These surfaces control the aircraft in pitch about the lateral axis. The controls must be adequate to balance the aircraft throughout its speed range, at all permitted center of gravity positions and configurations.
Okay, no? Ulitin ko lang, yung rotation around the lateral axis is pitching. It is being controlled by the elevator. So, we have three axes, no? Sa aeroplano, we have the longitudinal axis, lateral axis, and the normal or vertical axis. So, those three axes are intersect at a common point in an aircraft, which is also known as the center of gravity. So, yung tatlong axis na yon, nag-intersect siya at one common point sa airplano natin, which is known as the center of gravity. Ideally, no, if you're going to design an aircraft, ang center of gravity must be located within the portions nung cord, nung root, nung pakpak. Okay? So within those parameters, ideally doon kadalasang yung range no ng CG or yung CG limits mo doon sa eroplano. It is in terms of the percentage of the chord ng wing. Okay? So, we'll continue with pitch control.
And to give an adequate rate of pitch for maneuvers. The pilot controls the elevators by the use of a yoke or control column. This control operates the flying control surface and is moved in a fore and aft direction by the pilot to control the aircraft. If the pilot pulls the yoke or control column towards himself, then the elevator moves up. The degree of movement of the cockpit control directly affects the angular displacement of the control surface. This movement produces an aerodynamic downforce on the tail, which will pitch the aircraft nose up. If the pilot pushes the yoke or stick away from himself, then the elevator will move down. An up force will now be produced on the tail, which will pitch the nose of the aircraft down.
Okay, no? So that's how to control yung pitch ng isang aeroplano na or yung elevator natin. So by means of pushing or pulling the control column or the yoke or either the control stick. So doon magno-nose up or magno-nose down yung ating aeroplano.
Varying the incidence, and hence the angle of attack of an aerofoil, will also vary its lift.
Okay, so this is a variable pitch stabilizer. As you can see, no, ang spelling dito ng stabilizer is S. This is British English kasi. In American English, we are using that as Z. So stabilizer. But those two terms are correct naman, no?
This system is often used instead of elevators for pitch control. The whole of the tailplane or stabilizer is rotated to vary its angle of attack.
Okay, so in this regards, no, the whole of the tailplane or the entire horizontal stabilizer can be rotated to vary its angle of attack. And ito na yung mismong nag-act as the elevator. Kasi 'di ba ang elevator is commonly located at the trailing edge ng ating horizontal stabilizer. Pero dito, yung entire tailplane na yung mismong gumagalaw, no? Nagva-vary ng angle of attack to control the pitch ng eroplano.
If the yoke is pushed forward, the leading edge of the stabilizer moves up and the trailing edge down.
Okay, ganun din naman, although kanina kasi elevator lang yung nag-deflect, no? Either up or down. Dito naman, yung entire stabilizer na yung gumagalaw. Okay? So kapag minove natin or pinush natin forward yung ating control column, so ang tendency ng stabilizer natin is to move upward.
This increases the lift generated by the stabilizer, so the nose of the aircraft pitches down. If the yoke is pulled back, then the stabilizer rotates in the opposite direction, and the nose pitches up.
So that's almost the same in the operations of elevator. The main difference is yung ano lang nila, no? Yung mismong position or actual location. Kasi sa stabilizer, yung buong horizontal, dito sa stabilizer, yung buong horizontal stabilizer na yung gumagalaw, hindi katulad dun sa elevator, sa leading edge lang, trailing edge lang nung horizontal stabilizer nagde-deflect up or down.
That is the end of the lesson. You should now understand that control in pitch is achieved using elevators or a moving tailplane.
Okay so yun. Either a moving tailplane or movable tailplane or by means of elevator. So doon natin nakokontrol yung pitching ng aeroplano. Then next, we're going to discuss the roll control.
In this lesson, we will discuss the various ways in which lateral control about the longitudinal axis of the aircraft is achieved.
Okay, no? So, yung rolling, okay, ang rolling natin is a movement about the longitudinal axis. Longitudinal axis, okay? So, ito, paikot siya dyan. So kung umiikot dyan, along the longitudinal axis yung aircraft natin, it is either rolling clockwise or rolling counterclockwise. So it depends, okay? It banks to the left or banks to the right. Or, yung sabi ko kanina, yung ating ailerons provide lateral control or control along lateral axis. And also, stability along the lateral axis. Pero, yung movement niya is around longitudinal axis.
The aircraft rolls about its longitudinal axis. Lateral control about this axis is primarily achieved by ailerons. There is an aileron on the trailing edge of each wing. The ailerons are operated by the control column or yoke. The ailerons are flap-type controls, but their angular movements are in opposition to each other.
Okay, yung movement ng ailerons are opposite to each other, no? Kunwari, ang right aileron mo is nag-deflect upward. Therefore, ang left aileron magde-deflect downward. So, lagi siyang opposite. Hindi yan parehas, no? Ang parehas lang doon sa pakpak is the flaps. So, kung magde-deflect yung nasa kaliwa, left wing, magde-deflect din pababa yung sa right wing. Actually, ang flaps naman, hindi naman nagde-deflect upward. Okay? Sa ailerons, opposite sila. So, kung halimbawa sa left wing, nag-deflect upward yung left aileron mo, therefore, the right wing, it will deflect downward. Hindi siya parehas, opposite siya lagi. So, ayan, the aileron's angular movements are in opposition to each other. So, one aileron is angled up, the other is angled down. So, kapag nakababa yung ailerons mo, naka-deflect pababa, it generates a greater amount of lift compared doon sa kabilang aileron na naka-deflect upward that generates minimum amount of lift. Since mas mataas yung lift na napoproduce dito because of the deflection or the downward deflection of the aileron compared dito sa right wing mo, therefore, it will roll clockwise, no? It will bank to the right because of the unequal values of lift in both sides of the wing.
When one aileron is angled up, the other is angled down. Consider the aircraft in the graphic. The left wing has the downgoing aileron. This will increase the camber and increase lift. The upgoing aileron on the right wing has a reduced camber, so its lift will be reduced. The lift forces are now out of balance, and the aircraft will roll to the right. It will continue rolling to the right until the ailerons are returned to the neutral position by the pilot. Movement of the control column or yoke is instinctive. If the pilot wishes the aircraft to roll right, the yoke is rotated right. Rotate the control to the left, and the aircraft will roll left.
Okay, so ganun yung movement ng control column, no? So kung gusto mong i-roll sa kanan yung yung aeroplano mo, so you're just going to rotate your control column to the right. Okay? Para mag-roll sa kanan. So kapag gusto mo naman na yung aeroplano mo is to roll to the left, so yung yung yoke mo is i-rotate mo na lang, okay, papunta sa kaliwa. So, yun yung niya, no? Yun yung operation niya, no? Almost the same lang din sa sa sasakyan, pero ang difference kasi ng sasakyan parang yawing yun Okay? Pero dito kasi it provides rolling movement dun sa aeroplano or around the longitudinal axis. Around or about the longitudinal axis.
An undesirable side effect of the use of ailerons is adverse aileron yaw. The increased lift on the upgoing wing gives an increase in the induced drag, whereas the reduced lift on the downgoing wing gives a decrease in induced drag.
Okay, so in aerodynamics, no, if you're going to increase the lift of a certain wing, you're also increasing the drag. Kasi lift and drag is directly proportional to each other. So if you're going to increase the lift, umi-increase din yung drag mo. So in regards to this one, we have a term called adverse aileron yaw or adverse yaw. Okay? So, since 'di ba sabi nga natin kanina, kunwari dito sa location na to, doon sa illustration, yung aileron sa left wing naka-deflect upward. So therefore, naka-decrease yung camber niya, so decrease aerodynamic forces. So meaning, mababa yung lift na napoproduce and mababa yung induced drag. Actually, ang induced drag is lift-induced drag. So ibig sabihin, ano siya, parang result siya, no, ng lift. So that is the actual result, or that is the drag resulted from the lift. So kaya siya sinabing induced drag or also known as lift-induced drag. Okay? So kung mababa yung lift doon sa location na yun, mababa rin yung induced drag. As we can see here, doon sa kanan, sa right portion sa right wing, yung right ailerons natin naka-deflect downward. It increasing the camber and increasing the aerodynamic force. Therefore, the lift is being increased and also the lift-induced drag or the induced drag is also increased.
The difference in drag on the two wings produces a yawing moment, which is opposite to the rolling moment. That is, a roll to the left produces a yawing moment to the right.
So this is the adverse yaw, no? Because of those increase in induced drag in either part of the wing, no? In the left wing or kung saan man naka-deflect upward yung ating naka-deflect downward yung ating ailerons. So it produces a yawing moment. For example, opposite siya sa kunwari sa roll. Kunwari magro-roll ka papunta sa kaliwa. Because of adverse yaw, it produces a yawing moment to the right.
And a roll to the right produces.
Tignan niyo yung figure, Diba, ayan, magro-roll ka sa kaliwa. But because of adverse yaw, there is a
which is
result of yawing moment to the right. So opposite siya doon sa movement na rolling to the left. Okay? And kapag nag-roll ka naman sa kanan, you're rolling to the right, it produces an opposite na effect that it tends to yaw to the left. So yun yung tinatawag nating adverse yaw.
It's opposite to the rolling moment. That is, a roll to the left produces a yawing moment to the right, and a roll to the right produces a yaw to the left. There are three main methods in common use to counteract this adverse yaw. They are differential ailerons, freeze ailerons, and aileron rudder coupling.
Okay.
We will now have a look at each of these methods.
So yun yung three methods, no, on how to counteract adverse yaw. Because adverse yaw kasi it can provide instability, no, doon sa control ng piloto sa eroplano. Kasi nga, imbis na you're just rolling to the right, but because of adverse yaw, there is a tendency of the aircraft to yaw opposite doon sa direction ng rolling mo. Okay? So, it can cause instability doon sa ating eroplano. So, unang method to compensate adverse yaw is by means of differential ailerons.
With differential ailerons, the aileron linkage causes the upgoing aileron to move through a larger angle of deflection than the downgoing aileron.
Okay, so yung deflection ng upgoing aileron is mas malaki yung angle compared dun sa deflection ng downgoing aileron. Kasi 'di ba sabi nga natin, yung aileron na naka-deflect pababa, okay, or downgoing aileron, mas mababa yung kanyang aerodynamic forces because of the decrease in camber. So yung aileron naman na naka-deflect upward or upgoing aileron, opposite, mali ako, baliktad, sorry. Yung aileron na naka-move or naka-deflect pababa, so it has increase in camber and increase in aerodynamic forces. So ang aileron naman na naka-deflect upward, so it has a decrease in camber and also a decrease in aerodynamic forces. And by means of that, adverse yaw can happen. So one way to compensate for that is by using a differential aileron, wherein yung upgoing aileron mo, yung aileron na magde-deflect upward ay mas malaki yung angle ng deflection compared doon sa aileron na nagde-deflect downward. Okay?
This increases the parasite drag on the upgoing aileron and reduces it on the downgoing aileron.
Okay, actually, no, ang total drag ng eroplano is equal to the induced drag plus the parasite drag. So that's the formula for the total drag ng aircraft. Induced drag plus the parasite drag. So ibig sabihin, since mas malaki yung deflection ng aileron mo, that is deflecting upward or the upgoing aileron, so it increases the parasite drag on that upgoing aileron. Okay? And reduces the parasite drag in the outgoing aileron. So if you're going to summation, if you're going to summate or you're going to sum the induced drag to the parasite drag from the left wing to the right wing, they are almost hindi man directly equal, no? Pero almost equal to each other because of the effect nung differential aileron natin. Kasi nga sabi ko kanina, total drag is equivalent to parasite drag plus induced drag. Okay? So kung yung isa is mas mataas yung induced drag kasi nga mas mataas talaga yung kasi yung induced drag na yun, effect siya ng mas mataas na value ng lift na napoproduce ng structure na yun, nung wing na yun wherein the aileron is deflected downward. So ibig sabihin, mas mataas yung lift, mas mataas talaga yung drag doon sa location na yun. So para ma-compensate mo yung adverse shock because of that effect, so baguhin mo yung deflection. So mas malaking deflection ngayon yung gagawin mo doon sa upgoing aileron. Therefore, it increases the parasite drag. Okay? And sa kabilang side naman, mababa yung parasite drag. So ibig sabihin doon sa kabila, sa left wing dito, okay, you're increasing the parasite drag even though your induced drag is also, kasi mababa yung induced drag kasi nga mababa yung aerodynamic force eh. Kasi lift-induced drag yan. Okay? So, kapag tumaas yung lift, tataas yung induced drag. Kapag bubaba yung lift, bababa yung induced drag. So, para ma-compensate mo yung total drag ng bawat isang wing, sa left wing and right wing, okay? So, you're increasing parasite drag doon sa left wing by deflecting it at a larger angle, yung upgoing aileron mo.
Thus reducing the difference in total drag between the two wings.
Okay, so that's the operation of differential ailerons. Yung upgoing aileron, mas malaki yung angle of deflection compared dun sa downgoing aileron.
Freeze-type ailerons achieve the same balance in drag by having the leading edge of the control surface designed so that it extends below the lower surface of the wing on the upgoing aileron, thus increasing its drag.
Okay. So, sa freeze-type ailerons naman, it also balances yung drag, no? Nung left wing and right wing. Kasi sa freeze-type aileron, yung leading edge ng control surface is tumatama sa hangin once it's being deflected upward. So, ito. Okay? So, yung leading edge of upgoing aileron extends below wing surface, increasing the drag. Okay? Since kasi, di ba, alam natin dito, kapag naka-deflect pababa yung ailerons natin, so there is an increase in camber and also there is an increase in aerodynamic forces. Mas mataas yung lift, mas mataas yung drag. Dito, since mas nag-deflect ka upward, so there is a decrease in the camber nung surface na to and also a decrease in aerodynamic force. One way to increase drag is by means of freeze aileron or freeze-type aileron. Na yung leading edge mismo ng control surface na yon or ng aileron or upgoing aileron ay tumatama, okay, or naka-protrude siya doon sa lower portion ng wing natin para tumama doon yung hangin, therefore increasing in drag. But ang problem dito, it is only used on slow and light aircraft because if it's being used in large airliners or large aircrafts that is operating at higher air speeds, so it can compromise the entire structure ng pakpak mo. Okay? So, applicable lang siya into low and light aircrafts. So, ayan Freeze-type ailerons balance the drag by having the leading edge of the control surface designed so that it extends below the lower surface of the wing on the upgoing aileron, thus increasing its drag. Okay? So you are trying to balance the total drag between the left wing into the right wing, depending kung ano yung naka-downgoing aileron, depending dun sa upgoing aileron. Basta kung ano yung downgoing aileron, doon yung may mas mataas sa value ng aerodynamic forces. Aerodynamic forces is lift and drag. Okay? So, pag tumaas yung lift, tataas din yung drag. Pag mababa yung lift, mababa rin yung drag. So, one way to compensate for that is by means of this one.
The downgoing aileron leading edge remains shrouded and produces less drag.
So sa freeze type aileron, kapag na-deflect siya downward, so shrouded siya, no? I mean, magte-take effect lang siya kapag yung mismong aileron natin is naka-deflect upward. Pero kapag downward, so hindi yan. Walang mangyayari, walang effect yan primarily.
Some aircraft may employ a control system using the principles of differential and freeze ailerons together. These are known as differential freeze-type ailerons.
Okay, no? There are some aircrafts that employs the combination of the operations nung yung freeze-type ailerons and also the differential ailerons. So, ang tawag na dyan is the differential freeze-type ailerons. So, di ba sabi natin kapag differential ailerons, mas mataas yung angle of deflection ng upgoing ailerons. So, as you can see here, mas mataas yung yung deflection, no? And also, mas protruded yung leading edge portion ng aileron natin doon sa lower surface ng pakpak that is intended to increase the drag.
Not only does the upgoing aileron travel further than the downgoing one, the leading edge of the upgoing aileron also extends into the airflow. In the aileron-rudder coupling system, the aileron and rudder systems are interconnected.
Okay, so this is the third one, or the third method on how to control or counteract adverse yaw. Okay, next is the aileron-rudder coupling. So they are interconnected. Yung aileron and rudder systems natin are interconnected to each other. So that kapag di ba kapag sa sa flight simulators, sa mga app or sa computers man yan, di ba? If you're going to look at this one, di ba, if you're, kapag nag-roll ka sa kaliwa, there's also a tendency of that aircraft to yaw to the left. Kumbaga, siya, interconnected to each other. Kasi kapag nag-roll ka sa kaliwa, parang nag-yaw, may kasamang yaw na rin eh. Okay, ma-experience nyo yan sa flight simulator or once you already, you're flying an aircraft, no? Actual aircraft. So, ang tawag dyan is the aileron rudder coupling. So, interconnected yung aileron and rudder systems natin so that when the ailerons are deflected, the rudder automatically moves to counteract the adverse yaw. So, yun yung tendency, no? Kaya, for example, you're gusto mong mag-roll to the right because of the aileron rudder coupling. So, kapag nag-roll ka sa kaliwa, sa kanan, nag-yaw ka na rin. Kumbaga, nag-turn to the right ka na rin yung aeroplano, no? So, yun yung tawag doon. To counteract the adverse yaw.
So that when the ailerons are deflected, the rudder automatically moves to counter the adverse yaw.
So, kunwari, ito, sa illustration na ito, no? Yung left aileron natin is moving upward. Yung right aileron natin is moving downward. Nag-deflect siya downward. So, therefore, by means of aileron rudder coupling, yung rudder natin is also deflecting to the left. So, anong nangyari dito, nag-roll ka sa kaliwa and at the same time, you are yawing to the left also, no? Para ma-counteract natin yung adverse yaw.
The ailerons are
Next, we have the inbound ailerons.
normally situated at the wingtip to give the greatest moment for the force produced. However, this also means that they cause the maximum twisting and bending loads on the wing.
Okay, ailerons are situated or commonly situated at the wingtip. Okay? to compensate for an increase in the turning moment. Kasi 'di ba practically ang moment is force times distance. Kasi yung pag-roll mo sa kaliwa, pag-roll mo sa kanan, that's a twisting moment. So ibig sabihin, mas malaking distance, mas malaki yung twisting moment mo. So, ibig sabihin, mas malayo or mas mahaba yung moment arm mo, mas malaki yung value ng twisting moment. So that's the reason why ailerons are commonly located outboard ng pakpak. When you say outboard, near the wingtip. Okay? Pero ang problem lang dito, kapag situated sa wingtip yung ailerons natin, it causes maximum twisting and bending loads nung pakpak.
As the aircraft speed increases, this can cause a loss of effectiveness or even reversal of the aileron.
So yun yung delikado, no? Kapag nag-increase ng speed yung aeroplano, yung wingtip twisting and bending can cause loss of effectiveness ng ating ailerons or worse, reversal ng control. Ibig sabihin, in spite na gusto mong mag-roll to the left because of the loss of effectiveness nung natin ng outboard ailerons because of the extreme amount of twisting and bending loads na naramdaman ng pakpak, imbis na mag-roll to the left ka, nagkaroon ka ng reversal ng control. Okay? Ang nangyari, nag-roll ka to the right. So it's very critical in regards to flight maneuvering.
To reduce these effects, the ailerons can be mounted further inboard.
Okay, so one way, isang method to reduce this effect, medyo ilayo mo yung ailerons mo dun sa wingtip. Ito kanina, medyo malapit siya sa wingtip kung makikita nyo dyan. Pero dito, medyo nagkaroon ng although outboard pa rin yung location niya, pero medyo malayo-layo siya konti sa wingtip natin to reduce yung twisting and bending loads ng pakpak.
The ailerons can be mounted further inboard. Alternatively, two sets of ailerons are often fitted. One set at the wingtip for use at low speeds when the forces involved are low, and one set inboard for use at high speeds when the forces are greater and could cause greater structural distortion.
Okay. There are some aircrafts wherein we have meron siyang inboard ailerons and outboard ailerons. Okay? Yung outboard ailerons, kadalasan tong ginagamit ng mga eroplano na fitted with those two during low speeds. Okay? Kasi nangyayari ang maximum twisting and bending loads sa pakpak at higher air speeds. Okay? So, ibig sabihin, to compensate for that, kapag higher air speeds yung yung nililipad ng eroplano mo, so ang gagamitin mo ngayon to control the rolling ng eroplano is by using the inboard ailerons. So, yung inboard ailerons is commonly used at high speeds. Okay? Pero may mga ibang eroplano na at low speeds, nagde-deflect yung parehas, yung inboard at outboard ailerons. Pero at high speeds, okay, once na nag-retract na yung flaps natin, automatically madi-disengage na yung movement ng outboard aileron. So yung mismo nagko-control na lang ng yaw is yung inboard ailerons.
On some aircraft, with both inboard and outboard ailerons, both sets are used at low speed. But once the flaps are retracted, the outboard ailerons are locked out, and only the inboards operate. On others, the outboard ailerons are used in isolation until the flaps are retracted. The system then switches to the inboards only.
Okay. Yung outboard aileron, commonly siyang ginagamit when an aircraft is flying at low air speeds, no? And yung inboard ailerons, kadalasan siyang ginagamit when the aircraft is flying at higher air speeds to reduce the effect of twisting and bending loads nung pakpak.
The trailing edge flaps, which are discussed in another lesson, and the ailerons, both occupy part of the trailing edge of the wing. For good takeoff and landing performance, the flaps need to be as large as possible. And for a good rate of roll, the ailerons need to be as large as possible. However, space available on the wing trailing edge is limited, and one solution is to droop the ailerons symmetrically to augment the flap area. They then move differentially from the droop position to give lateral control. This method is used throughout the Airbus fleet.
Okay, so itong drop ailerons, commonly, they are dropped symmetrically, no, to augment the flap area when there is a limited amount of wing trailing edge spaces available. So sabi nga rito, commonly itong ginagamit ng Airbus sa kanilang fleet, yung drop ailerons.
Another system uses the trailing edge movable surfaces to perform the operation of both flaps and ailerons.
Okay, there are some aircrafts na yung operation ng flaps and ailerons are already combined into one flight control, which is known as the flaperons. So they perform, okay, both the functionalities of flaps and ailerons. Actually, ang flaps, kadalasan ginagamit natin yan at instances wherein kailangan natin na mag-generate ng higher amounts of lift because ang flaps is also increasing the camber ng pakpak. So increasing the camber, it increasing your aerodynamic forces. So kadalasan natin ginagamit ang flaps during takeoff, climb, or also during approach and landing. Because during takeoff and landing, yun yung yun yung instances wherein we need to have a greater amount of lift being generated doon sa ating backpack. Siyempre, kapag takeoff, kailangan mataas yung lift, no, para lumipad ka. Siyempre, kapag sa landing naman, hindi naman pwede na basta-basta bigla kang mag-land. So the aircraft needs to land na mas mabagal, no? Yung mismong nagko-control nun is yung pakpak rin, no? So ibig sabihin, the wing itself produces a higher amount of lift during landing so that the aircraft will touch the ground, no, during landing ng mas okay. Hindi yung hard landing talaga, no? So, kadalasan doon natin ginagamit yung flaps. And commonly, ang flaps is nagde-deflect lang siya downward. Tapos, retracted na. So, hindi siya katulad ng ailerons na nagde-deflect upward or nagde-deflect downward. So, pababa lang lagi yung deflection niya. No? It increases the camber. So, yung flaperons, kasi di ba alam natin, ang ailerons, ang kanyang control ay opposite sa magkabilang pakpak. So, kung yung isa is upward, yung isa ay downward. So, yung flaperons natin, so meron siyang functionality wherein sabay sila na, for example, when it is being operated as a flap, so sabay siyang naka-retract downward or sabihin natin naka-deflect downward. Okay? Pero once it is being used as an aileron, so opposite yung movement niyan dalawa. So yung isang aileron yung aileron sa kabilang pakpak is nakaangat, yung aileron sa kabilang pakpak naman is nakababa.
Such
That's the flaperons.
devices are known as flaperons.
As you can see here, no, ayun na yun, yung buong structure na yan, yung control surface na yan, that's the flaperons. So it performs both the operations of flaps and ailerons.
They are shown here on the SkyStar Kitfox. Spoilers are devices for reducing the lift of an aerofoil by disturbing the airflow over the upper surface.
Okay. Spoilers. Sa aeroplano, commonly, no, ginagamit ang spoilers primarily to increase the drag ng aircraft. Okay? But spoilers can also be used to assist the ailerons during rolling. And occasionally, sabi dyan, to replace them.
Their use is fully covered in another lesson. They are normally considered as secondary flight controls. However, they are often also used to assist the ailerons and occasionally to replace them by reducing the lift on one wing but not on the other. Raising the spoiler panels will disturb the airflow over the wing and reduce the lift.
Okay, no? Yung spoilers, yung wing spoilers, okay, commonly located siya on the upper portion ng wing. So, umaangat siya to disrupt the airflow doon sa pakpak. Therefore, increasing the drag and reduces the lift. So, that's the function ng ng spoilers. Sa ailerons kasi, kasi diba, depending on the deflection, pwedeng ini-increase niya yung aerodynamic forces, pwedeng binababaan niya yung aerodynamic forces. Ang difference naman ng flaps at ailerons, actually yung nakapula, ang difference ng flaps sa spoilers, itong nakapula, yan yung spoilers, no? Commonly siyang located above the flaps. Okay? Itong flaps, ito yan, yung nasa baba. So yung flaps is used to increase the lift of the wing, wherein the spoilers is used to increase the drag. Okay? So, yun yung purpose niya. Sa ailerons, or sa rolling, kadalasan natin ginagamit ang spoilers kapag, alimbawa, kapag gusto mong mag-roll sa kanan, magde-deflect ka ng ailerons, magde-deflect ka ng spoilers ngayon sa right wing para bumaba yung lift and mag-increase yung drag doon. So, pag mas mababa na yung drag, mas mababa na yung lift sa right wing, and because of the deployment of the spoilers sa right wing, no, pwedeng hindi ka na mag-deploy ng spoilers doon sa kaliwa. Or pwedeng hindi mo na nga i-deflect yung ailerons eh. Because of the operation ng spoilers sa right wing, so nagkaroon ka ng decrease ng lift and increase in drag. So therefore, ang tendency niya is mag-roll na ngayon sa kanan. So that's how spoilers are used in roll control.
When a roll is instigated, the spoiler panels on the downgoing wing will deploy, while the outgoing wing will remain stowed. Unlike the aileron, spoilers can...
Okay, as you can see, no, ito yung sinasabi ko kanina, when a roll is instigated, the spoiler panels on the downgoing wing will deploy. As you can see here, the aircraft is rolling to the left. Okay, so therefore, the spoilers are being operated, okay, or deflected. As you can see, no, hindi lahat ng spoilers are deflected. Okay? Because sa spoilers natin, it is divided into two. So we have ground spoilers that is commonly used when the aircraft is on the ground to reduce the yung landing distance, okay? To increase the drag and reduce the lift, and to aid for the braking system na landing gears and also the thrust reversing system sa engines natin. And we also have a flight spoilers. So yung flight spoilers na to, these are the spoilers that can be used to compensate rolling. This is used to for roll control. Okay? So pwede siyang gamitin in coordination with the ailerons, no? Para mas maging effective yung ating roll.
Unlike the aileron, spoilers cannot increase lift, and so a roll maneuver controlled by spoilers will always result in a net loss of lift.
Okay, so ito yung disadvantage of using spoilers for roll control. A roll control maneuver, actually that spelling of maneuver is also the British English for that. A roll maneuver controlled by spoilers will always result in a net loss of lift. Kasi yun yung purpose ng spoilers to disrupt the airflow doon sa upper portion ng pakpak. So therefore, it results in a net loss of lift.
However, the spoiler has several advantages over the aileron. There is no adverse yaw. The raised spoiler increases the drag, and so the yaw is in the same direction as the roll.
Okay, so isang advantage ng paggamit ng spoilers for roll control is that walang adverse yaw na nangyayari. Sabi nga natin kanina, 'di ba, ang adversio is yung tendency ng aircraft. For example, if you are rolling to the right, because of adversio, there is also a yawing tendency, no, or a tendency to yaw to the opposite of that direction, no. For example, nag-roll ka sa kaliwa, because of adversio, there is a counteracting yawing moment papunta naman sa kanan. So by means of using spoilers for roll control, so there is no adversio that's being generated.
Wing twisting is reduced. The loss of lift is distributed across the chord, rather than being concentrated at the trailing edge.
Okay, so note wing twisting. Yung wing twisting is being reduced. Okay? Kasi it was distributed now, okay? Yung twisting moment is directly distributed doon sa ating chord. Hindi katulad kapag nasa aileron, may aileron. So commonly, no, is concentrated siya doon sa trailing edge ng ating pakpak.
It does not suffer from the phenomenon of flutter. Flutter will be explained in a later lesson.
So one advantage also of using spoilers for roll control is that the wing will not develop flutter. We already discussed flutter doon sa the recent modules, but we will discuss it more again doon sa on the succeeding topics.
Spoilers do not occupy the wing trailing edge, so there is more space available for trailing edge flaps.
So since spoilers are located on the upper portion of the wing, so it does not occupy the trailing edges. So mas malaki ngayon yung space that can be utilized for the flaps. So those are the advantages. Next, ito yung mga combination ng primary flight controls natin.
On some types of aircraft, rotation around two of the axes may be achieved with one control surface. For instance, the elevon, a combined elevator and aileron, is used on tailless aircraft to give both pitching and rolling control.
Okay, as you can see here, this is a Concorde. Kung makikita natin, wala siyang tailplane or wala siyang horizontal stabilizer. Okay? So, ano lang siya, wing and vertical stabilizer. Actually, this is a delta wing, no? Ang elevon is a combination of elevator and aileron. So, kaya nga siya elevon. Okay? So, ang elevon provides both pitching and rolling control on tailless aircraft. That's like this one, the Concorde.
The ruddervator is the name of the control surfaces on the empennage of a V-tail aircraft.
Okay, ang ruddervator naman is commonly used on V-tail aircrafts, no? Yung shape ng empennage niya is letter V. So, pag sinabing ruddervators, it combines pitching from the elevator and yawing control from the rudders. So, yun yung elevon and ruddervator. Elevon is elevator and aileron, and ruddervator is rudder and elevators. Ruddervator and elevon,
which combines both pitching and yawing control. The stabulator is a movable tailplane, combining the functions of horizontal stabilizer and elevator.
Okay, yung stabulator naman, also known as a movable tailplane. So yung buong tailplane natin yung mismong gumagalaw, no? So it combines the function of the horizontal stabilizer and also the elevators.
One of the few airliners to use a genuine stabulator was the Lockheed TriStar.
So Lockheed TriStar, so yun yung isang airliner na gumagamit ng fully functional stabulator to use as sa ano natin, no? Sa stability, okay? Horizontal stabilizer and also the pitch sa elevators.
That is the end of the lesson. Here are the important points you should take from it. Spoilers may be used for roll control, Remember that the panels on the downgoing wing will deploy, whilst those on the upgoing wing will remain retracted. Inboard ailerons are used to reduce wing twisting for high-speed flight. The outboard ailerons are normally disabled when the trailing edge flaps are fully retracted. There are a number of methods used to counteract adverse yaw, the most popular being differential ailerons. With this system, the upgoing aileron moves through a greater angle than the downgoing one to equalize the drag on the wing.
Okay, so that's for the end of the roll control. Then we'll go with yaw.
In this lesson, we will discuss how an aircraft is controlled around its normal axis. We will also discuss the control position indicator, which is used to keep pilots informed of the position of their aircraft's flight controls.
Okay, so we will discuss these topics: how an aircraft is being controlled around or about its normal axis or vertical axis, and also regarding the control position indicator, which is used to keep pilots informed of the positions of their aircraft's flight controls.
Rotation around the normal axis is yawing and is controlled by the rudder, which is normally fitted to the trailing edge of the tail fin.
Okay so ang rudder is commonly located at the trailing edge ng tail fin. Okay, or yung ating vertical stabilizer. It's being operated by means of the rudder pedals.
The rudder is required to maintain directional control with asymmetric power, to correct for crosswinds on takeoff and landing, to correct for adverse yaw, to recover from a spin, and, on a single-engine aircraft, to correct for changes in propeller torque.
Okay, isang method in correcting, kasi for example, for single-engine aircraft, yung engine mo is nasa nose portion, it creates a torque. Okay? Kumbaga, merong may effect yung torque doon sa aeroplano natin. Kunwari, if the propeller is rotating counterclockwise, there is a tendency of that aircraft to yaw to the right. Okay? One way to compensate for that is by means of deflecting of your rudders. Actually, hindi naman yung buong rudders yung yung dinedeflect, no? We were going to discuss on regarding those component later on in the succeeding topics. Pero yun yung one of the functions. Kasi one small deflection ng rudder natin, it will generate a huge effect doon sa aeroplano. Okay? So yun yung yun yung mga functions ng rudder natin.
The rudder is a flap-type control and is controlled from the cockpit by the pilot's feet moving the rudder pedals. Pushing forward on the right rudder pedal moves the rudder to the right, generating an aerodynamic force, causing the nose of the aircraft to yaw to the right. Putting on the left pedal causes the opposite to happen, and the nose of the aircraft will yaw to the left.
So yun yung nasabi natin kanina in regards to the control of the rudder by means of the rudder pedals. So kapag pinush mo yung left rudder pedal, it will deflect, yung rudder natin will deflect to the left, and therefore your aircraft will yaw to the left. Kapag pinush mo yung right rudder pedal, yung rudders mo, o yung rudder mo in particular, will deflect to the right, and the aircraft will yaw to the right. So kung nasaan yung deflection, so doon yung direction ng yawing. Kung ano yung pinush mong rudder pedal, so yun din yung direction ng yawing mo.
With a simple control system, full rudder pedal movement will provide full rudder deflection. With high-speed multi-engine aircraft, it is necessary to have large rudder deflections available at low speed to allow the aircraft to be controlled in the event of engine failure. However, when flying at high speed, full rudder deflection would cause excessive loads on the structure.
Okay. When an aircraft is flying at low speeds, so it needs to have a larger deflection of the rudder. Okay? To improve the efficiency of its yung control niya, or movement. Pero kapag ang aircraft is lumilipad at high speed, so it is not directly recommended for that large deflection of the rudder because you are compensating for this entire structure ng tail fin assembly mo or yung vertical stabilizer mo, no? So there is a means na mabago yung angle of deflection or yung mismong yung pag-deflect ng yung rudder natin, okay, at low speed and high speed. So that's the term. Ito yung yung component na tinatawag na rudder ratio changer.
To prevent this occurrence, a gear change system, known as a rudder ratio changer, may be incorporated into the rudder control system. This may be a single gear change, which gives a smaller rudder deflection for full pedal movement above a certain speed, or a progressive gear change, which gives a decreasing rudder deflection with full pedal movement as speed increases.
Okay, so as aircraft speed increases, so mayroon nangyayaring gear change system, no, doon sa ating rudder pedals. So, meron tayong tinatawag na rudder ratio changer. So, naka-incorporate na siya sa ating rudder control system wherein it decreases the rudder deflection with full pedal movement. So, ibig sabihin, kahit na same yung yung movement ng pedals mo from low speed to high speed, basta ma-sense niya na yung aircraft is already flying at high speed, it will minimize the angle of deflection ng rudder natin. Okay? Para hindi masyadong malaki yung effect doon sa movement ng aircraft and also in regards to the stability and doon sa structure ng ating vertical stabilizer. So yun yung tinatawag nating rudder ratio changer. So at low speeds, malaki yung malaki yung deflection, pero at high speed, okay, yung deflection ng rudder natin was decreased. So there is a gear change na nangyari doon sa ating rudder control system.
This graph depicts the operation of a typical ratio changer. You can see that full rudder is available up until 160 knots. The travel then reduces progressively until at 380 knots, only approximately 3 degrees of travel is available with full pedal deflection. You now know how the aircraft is controlled about its 3 axes. To keep the pilots informed of what the primary flight controls are doing, their positions are displayed on an indicator on the flight deck.
Okay. For the pilot to know regarding in deflections ng kanyang flight controls, kasi actually hindi mo na makikita yan kapag nasa loob ka ng aircraft, no? Actually, hindi mo makikita yung tail. Yung horizontal and vertical stabilizer, lalo kung masyadong malaki yung aeroplano mo. Siguro, yung flaps or ailerons, pwede. Yung sa may pakpak, no? Pero actually, no, it is difficult for the pilot to visually check regarding the deflection or yung operability ng kanyang control surfaces, no? Kung halimbawa, kung ilan yung angle of deflection, kung depends, no, kung regarding sa flaps, etc. So there is an indication or indicator that is located in the cockpit that provides information to the pilot about the flight controls, the primary and secondary flight controls ng aeroplano. As you can see here, yung control position indicator, so we have here for Airbus and we have for Boeing.
There are a number of different systems used for this. Displayed here are the systems used on the Boeing 747 and on Airbus aircraft. The older electromechanical indicator for the 747 is quite simple and self-explanatory, but rather limited in what it can display. The electronic indication on the Airbus Electronic Centralized Aircraft Monitor, ECAM, on the other hand, is able to display a wealth of information. The letters beside the individual surface indicators show the status of the hydraulic systems operating the surface. They are normally green, but change to amber in the case of a failure. In this graphic, the blue hydraulic system has failed.
Okay, so sa Airbus, no, in regards to the Electronic Centralized Aircraft Monitoring or yung ECAM, so doon mo makikita yung indications regarding your flight controls. Okay? So makikita mo dyan yung sa spoilers or yung speed brakes in particular. So yung ailerons natin, level of its deflection, kung fully deflected ba or hindi. As you can see, no, yung right ailerons natin naka-deflect upward, etong left ailerons natin deflected downward. Kasi nga, di ba, magkaiba siya, opposite in regards to the direction. As you can see here, yung blue hydraulic system is amber in color, so there is a problem. Okay? Or inoperability doon sa ating blue hydraulic system, kaya siya amber in color. So ito naman, sa rudder, so ano rin siya, no, indication din siya, no, para malaman mo kung ilan na yung angle of deflection ng rudder, either in the right or left position, and also the elevator, the level of yung angle ng deflection ng elevators, and also the trim tabs, so nakalagay din naman yun dyan. Okay, so yun yung indication regarding the flight controls.
That is the end of the lesson. You now know that control in yaw is achieved using the rudder. Also remember that modern airliners have some type of rudder ratio change mechanism to reduce the amount of rudder travel at high aircraft speed.
Okay, so that ends our the discussion for our synchronous meeting for today.